Okay, so in this video we're building off of what we did in the last video, which was using matrices to solve systems. In that video we solved systems of two linear equations and two variables. Now we're going to use matrices to solve systems of three linear equations in three variables. So in a system of three linear equations with three variables, the solution of the system is an ordered triple. X, Y, Z are typically the variables that we use. However, you can use any variables you like. A, B, C, E, F, G, it doesn't really matter. But what I'm going to do is typically use X, Y, Z. Now, to be a solution like we saw in the earlier videos, the ordered triple has to work for all three equations in the system. So what we want to do in example 10 is to verify that 2, -1, 1 is a solution to the system. So I'm going to do some scratch work. Top equation is going to be in green. And essentially everywhere I see an X in all three equations, I'm going to plug in a 2. Everywhere in all three equations I see a Y, I'm going to plug in a -1. And in all three equations where I see a Z, I'm going to plug in a +1. Again, this solution has to be true for all three equations to verify that it is in fact a solution. So for the first equation I have 2 plus 2 times -1 minus 3 times +1. And that's supposed to be equal to -3. Well, I want to clean this up as much as I can. So I have 2 plus -2 minus 3 equals -3. Now, positive negatives and negatives, so I have 2 minus 2 minus 3 equals -3. And hey, 2 minus 2, those just cancel out, so I'm just left with -3 equals -3, and that for sure is true. So the first equation works. Let's do the second equation in blue. Alright, so I have 2x minus 5y plus 4z equals 13. So again, I'm just plugging in my order triple. So 2 times 2 minus 5 times -1 plus 4 times +1 is supposed to be 13. Clean it up as much as I can. 4 plus 5 plus 4 equals 13. Well, 4 plus 5 is 9 plus 4. And I know for a fact that 9 plus 4 is 13. So the second equation works. And then for the last equation, at 5x plus 4y minus z equals, it's supposed to be equal to 5, so I'm going to do that in red. So 5 times 2 plus 4 times -1 minus 1 equals 5. And like we've been doing, just clean it up. So 10 plus -4 minus 1 is supposed to be 5. Positive and negatives, so 10 minus 4 minus 1 is equal to 5. 10 minus 4 is 6, minus 1 is 5. And 6 minus 1 is for sure 5. So since this order triple works for all three equations in my system, then I know for a fact that this order triple, 2, -1, +1, is in fact the solution to this system. And when we graph, if we were able to actually graph these linear equations in three variables, again we use X, Y, Z. We can't graph it on our calculators, but some of the newer advanced calculators can, and for sure some of the new advanced computer programs can. If we graph these systems, what we would see is that we have different possibilities. If the planes intersect at a single point, then the system has exactly one solution. If all the planes intersect along the line, then there's infinite solutions. And then down here, if the planes intersect pairwise, which means say pink plane with green plane, blue plane with green plane, or blue plane with pink plane, there's no solutions because to be a solution, all three have to intersect together. In this picture, you only have pairs intersecting, so there's no solution if the system would look like that. But then also, the graph, when we graph these linear equations on three variables, the graph is a plane, which we think about as a sheet of paper. So here in this picture, it's kind of like we got 3 sheets of paper all parallel to each other. And so they never ever touch, and since they never touch, no solution. So just like we saw with systems of two linear equations and two variables, in that video we had one solution, infinite solutions, or no solutions. Same thing when we have three linear equations and three variables. We're going to have one solution, infinite solutions, or no solutions. There's no other possibilities. It's always one, infinite, or none, if you're talking about linear equations. Unfortunately, like I said at the beginning of this video, we cannot solve this system, a system of three linear equations with three variables. We can't solve it by graphing using our calculators. Some of the newer calculators can, but unfortunately we don't have access to those. So, and you could do algebra, however, I'm not going to punch you through that because it's a very long, drawn-out process. Instead, what we're going to do is we're going to build on that idea of matrices in the reduced row echelon form, or REF, that we saw in the last video. It's just like what we did in the last video. In the last video, we had two linear equations and two variables, and we talked about we had an x column, a y column, and a constant column. Same idea when we have three linear equations and three variables. We're going to have an x column, a y column, and now a z column, and a constant column. Just like we did before, when we do a matrix, we need to know how many rows. Rows go horizontally, columns go up and down. So we have three equations, so we have 3 rows by 4 columns, an x column, a y column, a z column, and a constant column. So we have 3 rows by 4 columns. Now, before you do anything in the calculator, it's very important to remember, anytime you're using a matrix, your variables have to be on the left. So x, y, z, all your variables have to be on the left side of the equation. Your regular constants have to be on the right side of the equation. Also, you want everything to line up nicely. So x is lined up with x's, y is lined up with y's, z is lined up with z's. Constants lined up on the right side with constants. If that's not already done for you, then you need to do some scratch work. Fortunately, in this problem, everything's lined up correctly the way it's supposed to be, so we're ready to use our calculator. So what we're going to do is go to our main screen. I want to go second matrix like we did in the last video. We're going to start off in the edit menu, and I'm going to choose whatever matrix I want to work with. In the previous video, I used matrix A. I'm going to edit matrix B this time, just because why not? I can choose whatever letter I want to work with. Again, the calculator is asking how big is the matrix? So 3 rows by 4 columns, so 3 by 4, and then hit enter, and it gives you the spaces to plug in. And just like we did in the previous video, we're just telling the calculator how many of each type of thing we have. Do not type the variables. All you're going to do is for the first equation, I have 3 x's, 2 y's, 4 z's, and 11 constants. For the second equation, I have 2 x's, negative 1 y, 3 z's, and 4 constants. I have 5 x's in the third equation, negative 3 y's, and 5 z's, and negative 1 constant in the third equation. Now, what I would suggest is, especially if you got fat fingers like me, go through and make sure you got everything typed in correctly, because if you even miss one little thing, it's going to mess up your answer. So now that you have everything typed in, you want to go back to your main screen. Now you want to hit second matrix again. This time you're going to the math menu, and like we did in the previous video, we're looking for option B as in boy, R-R-E-F. So I'm going to hit enter. And now don't hit anything else. Okay, don't hit enter or anything like that. What we want to do is go back to the matrix menu, second matrix. This time we're in the names. Now, I use matrix B, so that's the one I'm going to select. If you use matrix A or matrix C or any other matrix, you need to select that matrix. It doesn't really matter which one you used, as long as you typed in everything correctly, we should end up with the same answers. So I use matrix D. I'm going to close up my parentheses and then hit enter. What the calculator generates, I call it the answer matrix. Okay, that's probably not the official name, but I call it the answer matrix. So I'm just going to write it down, because if you hit anything else, most likely you're going to lose this information and have to start over. So I really suggest you write the answer matrix down on your paper. And then we'll talk about what it means in just a second. Now, we had started off with 3 equations, so we have 3 rows in our answer matrix. That kind of makes sense. We also had 4 columns in our original matrix, so we have 4 columns in our answer matrix. That makes sense. And the columns are kind of in the same order. We have X, Y, Z, but now our last column is the answers. I call it the answers. Alright, so what the first row is telling me is that 1x is equal to negative 3. 1x is equal to negative 3. I have in the second part, I have 1y is equal to 2. And the last part, I have 1z is equal to positive 4. So once I have that information, I'm ready to write my final answer. Remember, an answer or the solution to the system is always an ordered triple. So I'm going to write it as -3, 2, 4. It's always x, y, z. So this is my solution to the system. We have exactly one solution to this system. Let's go on to another example. We want to solve this system. Again, I'm going to use a matrix to do that. Before I do anything though, I know it's a 3 by 4 matrix because I have 3 rows, supposed to have 4 columns. So 3 by 4 matrix, and we're going to eventually do RREF to get our answer matrix. So I'm going to go ahead and set that up, that way I'm ready to fill in everything when I'm ready. Now, again, like I said on the last example, all your variables need to be on the left side of the equations, all your constants need to be on the right side of the equations, and x's, y's, and z's and constants need to be lined up respectively. It looks like everything's lined up nicely in this example, so I do not need to do any scratch work. So now I'm ready to use my calculator. I'm going to go second matrix. Actually, I'm going to go clear out everything that's already there. Now I'm going to go second matrix. Again, we're in the edit menu. This time I'm going to do matrix C, just because I can. It's a 3 by 4. I'm going to fill in the first equation I have 1x, 1y, 1z, and 2 constants. Second equation, 3 x's, 3 y's, 3 z's, 14 constants. The last equation I have 1x, negative 2 y's, positive 1 z's, and 4 constants. Again, take a second, make sure you typed in everything correctly. Once you have, go back to the main screen. Then second matrix again. This time we're in the math menu. We're going to go RREF, option B. Now we need to go back to the matrix menu and pull up the matrix we just edited. So I'm in the names menu. Again, I edited matrix C. If you did any other matrix, pull that one up. As long as you typed in everything, you should get the same answer that I do. So I'm going to use matrix C because that's the one I was working with. Hit enter. And I'm going to write down my answer matrix. So I have 1, 0, 1, 0, 0, 1, 0, 0, 0, 0, 0, 1. Again, my columns were X, Y, Z, and my answers. All right, well, let's talk about what the first row means. I have 1x and 1y. They're both positive, so this means 1x plus 1z is equal to 0. Here, I have 1y is equal to 0. And down here on the bottom, I have no variables, no x's, no y's, no z's. So 0 is equal to 1. This is the thing I want to look at because there's no variables at all. Like we saw earlier in this chapter, in the earlier videos, when we had no variables at all and we get something that is never true, and no variables at all, that means no solutions. Okay, so no solution. So graphically, this would be either pairwise joining, so the planes would intersect the pairs, but not all three together, or they would be the sheets of paper that are all parallel, like we saw a few slides back. Okay, so again, you're looking for something where you don't have any more variables, something that's never true, that means no solutions. Okay, no big deal. Let's move on to do another example. Example 13. Again, I'm going to use a matrix. Looks like everything's lined up correctly. All my variables on the left, x, y, z, are lined up nicely. All my constants on the right, and the constants are lined up nicely. So I'm ready to use my matrix. I know it's going to be a 3 by 4 matrix. I'm going to use RREF in my calculator. And when I do that, I'm going to get my answer matrix. And it's going to be x, y, z, and my answer. So now let's plug everything in our calculator and use that. So I'm going to clear this out, go to second matrix, go to the edit menu. This time I'm going to use matrix C again, so I'm just going to select C and edit it. It's already set up for a 3 by 4 matrix, so that's good. Now I'm going to just type over whatever I had in the last problem and put in my information for this problem. So in the first equation, I now have 1x plus 1y plus 1z and 2 constants up top. In the middle equation, I have 1x plus 1y minus 1z, and there's 2 constants. And in the last equation, I have 2x's plus 2y's plus 1z is equal to 4 constants. Now that I have everything typed in correctly, I'm going to go back to my main screen, back to the matrix menu, this time to the math menu, and I want to select option B as in boy. Now I want to go back to the matrix menu. I'm in the names menu. I was working in matrix C, so I'm going to pull that one up and then hit enter. And I get my answer matrix. I want to write everything down before I do anything else. Before I lose it, so I have 1x, 1y, 0 z's, and 2 is supposed to be my answer. 0, 0, 1, 0, 0, 0, 0, 0. All right, let's talk about what each of these things mean. In the first row of my answer matrix, I have 1x and 1y, and it's supposed to be equal to 2. So both of these are positive, so this translates into 1x plus 1y is equal to 2. In this row, I have 1z is supposed to be equal to 0. And in this last row, I have 0x, 0y, 0 z's, and that's supposed to be equal to 0. So 0 equals 0. I ran out of variables. I don't have any variables represented here, so that's kind of the problem. But this part is always true. I know 0 is always equal to itself. So when you run out of variables and you end up with something that's always true, that means infinite solutions. Okay? So in the previous example, we had 0 equals 1, something that's never true. This example, we have 0 equals 0, something that we know for a fact is always true. So it's always true means infinite solutions. So again, matrices are very nice because it doesn't matter how big the system gets. For instance, Walmart, when they're doing inventory, they use systems of equations to represent all the items that they stock on their shelves. Now, those matrices that solve those systems are incredibly, incredibly large, so they use very powerful computers to do that. But it's the same idea what we're doing. Just the matrix dimensions, the rows and columns are a little bit bigger, but they're still doing RREF, like we just did here. So matrices, in fact, there's whole branches of math, just whole classes in college of math that are just on matrices. So it's a very important thing. We barely scratch the surface of it. As always, though, if you need any help, let me know.